Hi, DroidCon Uganda, and welcome to my talk Kotlin 2.0 at K2 and the Brilliant Future. My name is Pamella Hill. I'm a developer advocate at JetBrains. Thank you for joining me today. So we're going to start with a very quick little history lesson, but don't worry, it won't be boring. It's about Kotlin. So let's go through what how we actually got here. So in July 2011, the Kotlin project was announced at the JVM Language Summit. And in 2016, Kotlin 1.0 was released. In 2017, Google announced official support for Kotlin on Android. And in 2019, it became Kotlin first support on Android. In this year, in 2024, Kotlin 2.0 was released. And Google has also announced the same year that there is official support for Kotlin multi-platform, at least for business logic. So that's quite an impressive journey from 2011 to 2024. And we've seen that over the years, more and more people have started to use Kotlin. And at the moment, according to 2023 stats, so I'm sure that it has increased, there are 2 million active users, people that regularly use Kotlin. So what do they actually use Kotlin for at the moment? So it's definitely Android, that one I'm sure you know. There's also server-side, so Spring, Ktor, and so on. Kotlin multi-platform, which is Android, iOS, desktop, web, and server. There's scripting, so you can think of all the scripts that you write maybe for your Android application. Those could all be, if it's KTS, it's definitely Kotlin. And data science, so all those Kotlin notebooks. And there's also a massive ecosystem of tools, libraries, compiler build tools, and IDEs. That's a lot of ecosystem. So perhaps you have your favorite Kotlin features. I definitely do. So I'd like to share a few of my favorites with you. So the first thing that I really liked about Kotlin was data classes, because it was a more concise replacement for plain old Java objects. Next, coroutines, because it's much more readable way to write concurrent operations. DSLs for creating like a little mini language, usually for setup of some kind. And of course, null safety for keeping your app from crashing with a dreaded null pointer exception. And so on. So in summary, I really liked Kotlin because I could use this modern language for Android and more. Now with Kotlin multi-platform, I can develop for iOS too. So we saw that Kotlin 1.0 was released in 2016, and a lot has happened since. Coroutines was also added and multi-platform. But progressively, the team at JetBrains started adding more and more features, like more features like the ... less than operator and so on, and then even more features. So the language was evolving super fast. But the truth is that the language was built on a prototype compiler that was hardened, shipped, and evolved. What happens in these situations? Well, what happens always in these situations? Adding the features became harder. It became hard to maintain and evolve the compiler. And we needed a fresh start. We needed Kotlin 2.0 and K2. Now, the compiler frontend is the backbone of the Kotlin ecosystem. The front end sort of feeds all of its work, called IR or intermediate representation, into the platform-specific backends. So that is Kotlin JVM, JS, WASM, and so on. And many tools and libraries actually rely on the work of the front end as well. So why did we actually need this new compiler K2? Firstly, it's about adding more and more features that had a maintenance cost. Features like multi-platform support, that was a huge feature. It's like a mega feature. It was also about interaction with the IDEs that were mostly ad hoc without an API. But now it's possible with K2 also to add compiler extensions. Even you could write compiler extensions, like everybody can write compiler extensions for K2. Compiler time performance also needed to be improved. It's true that nobody's really ever satisfied with performance, especially with a growing number of clients and the code base size. Why did we need to evolve Kotlin into Kotlin 2.0? There was firstly a focus on performance and correctness, and more than 80 features was added in different subsystems, and around 25 small features and improvements in the language. Let's have a look at some high-level changes that made to the compiler. So first we added some the front-end intermediate representation, or FIR, and it basically just means that the language constructs were broken down into simpler ones. There was also now more phased approach to analysis, with isolated analysis for language constructs and extensions for the IDE and compiler plugins. And there was also a new control flow engine, with improvements for type inference and resolution. So to put it practically, if we have this diagram to show how the Kotlin compiler works, we see that we have some Kotlin source code in cat.kt, and that front end is then going to translate the source code into IR, or intermediate representation. Then the backend will take this IR and produce platform-specific code. So we're using the Kotlin JVM backend, so then we get cat.class that can be run on the JVM. If we look at a multi-platform scenario, the front end can still translate the Kotlin into IR, but the Kotlin platform backends now translate the IR into different things for different platforms. So for example, Kotlin native will be native binaries, Kotlin WASM will be translated into WASM files, and so on. In K2, the front end has multiple phases, including the parsing phase that gives us the FIR, and the an analyzer phase that takes this FIR results and transforms it to IR. In FIR, or front-end intermediate representation, just a reminder, language constructs are broken down to simpler ones. For example, an if condition becomes a when, a for in loop becomes just an iterator that we use a while loop with, and a pairs deconstruction is changed to just calling the deconstruction component 1 and component 2. But the first effect of doing this, of breaking language constructs down into more simple constructs, is that we get better correctness. I'm not really sure that's proper English, better correctness, but let's pretend that it is. So we're going to go through a couple of brain teasers. So what do you think? Will the following bit of code compile? So we have a function called mutate that takes in a mutable list of longs, and the only thing that we want to do is we want to take the first index of that list and just add one. Will this compile? What do you think? Well, actually, it depends. In Kotlin 1 point something, we get a compiler error as a long value is required. But in Kotlin 2.0, we don't get one because the statement is desugared into this statement where we say ml set with the index 0, you get the first one at the first index value, and then you add 1. So we don't need to pass in a long value because an int is understood in this context. Another brain teaser. Will the following compile? So we have a class box that takes in a mutable list of longs, and then we have mutate function call that takes in a box, and that box could potentially be null. Then we want to add to the first index value, we want to add one int and one long. Will this compile? What do you think? Well, again, it depends. In Kotlin 1 point something, we get a compiler error because we might be assigning to a null value variable box. But in Kotlin 2.0, the two assignment statements is desugared into this question mark.run sort of statement. And here we're making sure that we're not trying to assign a non-null value or a null value using the question mark run trick. We also have the second effect, and that is that we get more and better smartcasts. Also not sure if that's proper English. So let's look at some code. Say we have a class called cat that has a function per. And we also have a top level function called pet animal that takes an animal, any animal. And if the animal is a cat, we make it per. So this is all correct. Next question is, if I take this animal is cat condition and I put it in a variable, and I make this variable the condition on which I determine whether I call per or not, will this still compile? What do you think? Well, not in Kotlin 1.x because the variables don't carry data flow information. Well, we can't tell at compile time whether it is legal for the animal to per. But in Kotlin 2 point something, as you probably guessed, we can move this condition out because synthetic data flow variables propagate information about smartcasts. So it's almost like this variable has extra information that will be able to tell the compiler that it is legal for the animal to per if based on this variable that we've got. So I'd like to also just focus a little bit on the features that will be coming soon, not just the K2 features that we've seen now. So some upcoming features, we've got guards in version 2.1. We've got multi-dollar interpolation in 2.1 as well. We've got name-based restructuring in 2.2 and union types for errors in 2 point something. It's still being decided exactly where. There are also other features like context parameters and contracts, but we're not going to discuss that today as they're a little bit complex. It's not that I don't think you can handle it, it's maybe just very niche. Right, so next we have guards. So we want to look at guards first. So let's look at the following code. We assign the variable order to the result of calling this function called getOrder. So when we have this when statement. So our first line is if the order is a yearly subscription and the amount of that order is bigger than or greater than 100, apply a discount. If the order is a monthly, start the subscription, and if it's a one-time order, just process the order. Okay, seems reasonable. But there are a couple of things that are maybe a little bit icky about this code. Firstly, this is potentially a logic error, because what happens if the order is a yearly subscription with an amount less than 100? Is this a logic error? Where's the default case, right? Also, the repetition of order is not very nice. So how can we actually go ahead and improve this? Well, we would like to add, so firstly, we need to add the is yearly subscription just like it is. But then when we look at the double ampersand or double and, we see that we're actually going to get a compiler error because we're not actually allowed to have that in our conditions for the for a when statement. So instead of that double ampersand, we can change it to an if and start using guard conditions. So the compiler is also going to help us with guards if we accidentally have the wrong order for the when conditions. For example, here we will never reach that second branch, as the first branch will always catch all the yearly subscriptions. So we will get a compiler error here. We should also later be able to have less repetition of the order variable by making the when statement based on that variable while using guards, but that's a coming feature. Next, let's have a look at a problem related to string interpolation. Say that we have some JSON that looks like this. Note that I have 3 of the keys that start with $. So we have schema, ID, and dynamic anchor that will start with $. So when we wrap this JSON in a multi-line string, we get a compiler. We're gonna get a compiler error because the compiler thinks that schema, ID, and dynamic anchor refer to variables and should be calculated and replace the variable names with the variable values in the JSON. Of course, we could try something else in order to make the compiler think something else than that this is an unresolved reference. We could try this, but this is a nightmare and let's not do that. So instead, we're going to use multi-dollar interpolation for Kotlin 2.1. When we want to use it, we start the string with $, and then whenever we want to replace a variable name inside of it, we start it with $. So that was rather intense. I hope you're still okay. Let's take a quick breath before we get into the code again. Ready? Okay. So next we're going to look at a way to avoid making common mistakes in destructuring data classes. Now we've seen get order and we're kind of used to get order now. But here we can see that we split up the order variable into ID, name, and amount variables. But what happens if we accidentally swap the variables ID and name? So instead we have name, ID, and amount. In Kotlin 1, we'll definitely get a big nasty bug. But in Kotlin 2.2, we need to name all of these structuring variables after the variables in the data class, and this is going to prevent a few nasty bugs. Isn't that cool? Lastly, we're going to look at union types. Say that we have this search function where we try and get the last order above a certain threshold. The condition here is the amount is bigger than the threshold. Let's look at the last function. So you can see that we're just looping over the orders, and if the element matches the predicate, we have the result, and if we don't have a result, we throw an exception. But what if the predicate is it equals null? So this implementation will have to change, and it is way more intricate because we have to add an element that is found or not found, or found in order to be able to determine whether we need to throw the exception or not. So it would be nicer to improve this without using an extra variable like we had before. We had found. We could have an object called not found, which is used to identify the not found case, and then throw an exception if the condition isn't found. But there are really two kind of really icky things about this piece of code. Firstly, that we're using the any ? Type, so the nullable any, and we have an unchecked cast here. That's also not great. So instead, we can use in Kotlin 2.2 or Kotlin 2 something union types for errors. Why? Here we can see that any becomes T bar not found or T pipe not found. I don't know how you pronounce that. And we have a smart cast instead of an unchecked cast. So much better. So if you are keen on learning more about the Kotlin roadmap, and I would really recommend that you have a look at the following 2 pages. One for the roadmap, just in Kotlin Lang docs roadmap. And the other one is sort of like a sub-page of this, where it has all the potential language features and proposals documented there. Now that was quite a mouthful. And it was a rough learning curve, even for me. So learning curves sometimes feel like this. Beforehand you're like, wow, that's so much learning to do. And while you're going through this, you're like, oh, I'm not going to make it. But then afterwards you think, oh, that wasn't so bad. And then the next time you're going to make it. All right. Time for the Q&A, and thank you so much for listening.